All right, y'all. Hello. Um, so today, here's what I've got for you is 6.7, which is integration by parts. So let me figure this out. Give me a sec. Give me a sec. Share this. Okay, cool. Okay. So integration by parts is a way to integrate. For right now, let me, just for the first example, let's just do it, take my word for it, this is how you do it, and then I'll explain where does it come from and what's the intuition. So integration by parts is a way to integrate integrals that look like this: function times function. And a preview of the explanation behind it is that it's undoing the product rule. More on that later, but how is it done? Basically, you follow the formula that I'm pointing at right now with red, where the u and the dv, you are kind of choosing. How do you choose it? It's going to be something like this. So I like to set it up like this: u, du, and then dv and v. And you are filling out u and dv, and du and v are the ones that you have to figure out with like math. So how do you choose u and dv? You choose them like this. Choose the u so that it is, most of the time you choose it so that its derivative is a little bit simpler than originally. So most of the time you're going to choose u to be like a polynomial, like x or x squared or x cubed or whatever. And then you're going to choose dv to be everything else. Like everything that is not your u will be your dv. So in this case, u is going to be x, and dv will be everything else. So once the x is gone, pretend this x isn't here, then the e to the x dx will be my dv. Okay, cool. And then once you have that, then you figure out du and you figure out v by, well, to get from u to du, you take the derivative. So this would be 1 dx. I'm just going to write the dx. And then v, to get from dv to v, you take the antiderivative. So what's the antiderivative of e to the x? Oh, it'll be e to the x again. Plus c technically, but you save that for last. Okay, and then basically you follow the formula right here that I'm circling. So in this particular case, once you choose your u and your dv, u and, well, here's me following the formula. Integral of x e to the x dx will be equal to uv, so in this case, x times e to the x, minus integral of v du, so e to the x dx. Cool. And then you're still not done because there's still an integral in here, but you know what the antiderivative of what I'm circling is right here. So this, oh, hang on, the light just went off. Okay, so this would be nothing to do with that first term, but minus integral of e to the x is just e to the x plus c, and then that should be your answer. All right. So very cool. And then if you're ever like, I'm not sure if I did this right, then you could always check your answer over here by taking the derivative of your answer and seeing if you get your original back. Do you have to do this? No, but it's like if you're unsure, then do it. So here's me doing it. Derivative, you can skip ahead in the video if you're not trying to watch me check this answer. Although I will say some intuition behind this in a second. So take the derivative of your answer, you would get, oh, product rule right here. So x times e to the x would be first times derivative of the second plus second times derivative of the first, which is 1. And then minus e to the x, and then the c has a derivative of 0. And then you can kind of see the intuition and the idea behind integration by parts is that when you just do the product rule, you get two terms, like first times derivative of the second plus second times derivative of the first. And so this extra minus v du, well, you can think of it as like getting rid of that extra term from the product rule, kind of. So this plus e to the x minus e to the x will cancel, and you're just left with that x e to the x that you had started with in the problem, so you know you did it right. Okay, very cool. So then, again, you can skip ahead if you don't want this, but where does this come from? Let me now show you the origin of this. So, I don't have that much room, but I can do it. I guess I can do it here, look at up here. So we know the product rule going forward, the derivative of f times g is equal to first times derivative of the second plus second times derivative of the first. Okay, so if I want the antiderivative, then you could take the integral of both sides with respect to x. Depending on when you're watching this, you already know that the integral of a derivative kind of cancels out and you just get f times g equals, and then let me split it up like this, f times g prime dx plus g times f prime dx. And then where this integration by parts comes from is if you move this to the other side, you get f times g minus integral of g times f prime dx is equal to the integral of f times g prime dx. Okay, and so, okay, I guess in the formula in the formal formula that I gave you, they use u and v instead of f and g, but this is equivalent. If you think of f as u and g prime dx as dv, then you can see u dv, then you would get u v minus v du. Okay, so that's the idea, or like that's where the formula comes from. And you can kind of see why you're choosing a u and a dv rather than choosing a u and a v, is because in the product rule, in both terms of the product rule, what I'm circling right here, you have one function left alone and one derivative function, so g prime. One function left alone, g, one derivative function, f prime. So you're choosing one function left alone and one derivative. All right, talk to me in person if that doesn't make sense, and I can explain it more specifically, but there's the idea behind all this. And that's basically the lesson, and then just a bunch of like examples to see if you can choose the right u and dv. Let's go through those, and then that'll be that. Okay, so this one, x times sine of 3x. Again, this is how I like to set it up. U, du, dv, and v. The u, by the way. And then you choose the right ones. So what would be the right u and what would be the right dv? Think about it for a second, Okay, hopefully you said x is right for you because the derivative of x is simpler. It's 1 dx. And then dv, pretend this x isn't here. That tells you what dv is. So dv has to be sine of 3x dx. Okay, and then what does that make v then? Well, that would be the antiderivative of sine of 3x, which if you're saying that's negative cosine of 3x, then you are wrong because there's a chain rule involved, or really a u substitution involved. It's really negative cosine of 3x over 3. And I guess the best way I can explain that is if I took the derivative of negative cosine of 3x and left it like that, then my derivative would be chain rule. Derivative of negative cosine would be positive sine of leave the inside alone times 3. Oh, shoot, this times 3 wasn't in the original sine of 3x, so I got to divide that away. That's why. That's why I got this extra division by 3. There's really, it's like a hidden U substitution. Again, if you don't see that, come talk to me in person and I'll answer the question specifically. But hopefully that makes some sense. All right, U, V, 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 everything is chosen. So now just follow the little formula. So integral of f times sine of 3x dx is equal to uv. So uv x times negative cosine of 3x over 3. uv minus integral of v du. Okay, very cool. Now let me simplify this a tiny bit because that'll make it a little bit easier. I'm gonna negative and negative here, I'm gonna combine those to be a plus. And then this 1/3, I guess I'll just keep that. Okay, so then what would be the antiderivative of this second integral? It would be and then antiderivative of cosine of 3x over 3 would be, for the same reasons that I talked about up here, it would be plus sine of 3x over 3, and then over another 3. So altogether over 9 plus c. Again, if you don't believe me, take the derivative of this. You'll see that we do end up with that again. It's going to be annoying because you got a product rule, you got all these fractions, but you can do it. All right, there you go. There's that one. Next one is a definite integral. Hang on, give me a sec. Okay. Next one is a definite integral, and I'm going to do it wrong on purpose at first, because this is one of the weird ones where the u and the dv isn't what you would expect. So watch this. Here's me doing it wrong on purpose. U, du, dv, and v. So don't write this down if you're taking notes. But if you choose your u to be what you would think, you would think u is x squared, because that's what I told you at the beginning of the video. But if you do that, then that forces dv to be the integral of natural, or sorry, not the integral, just straight up natural log of x dx. Okay, and then you go about your business, you do 2x dx here. And then antiderivative of natural log is, oh shoot, I don't know the antiderivative of natural log. If you're thinking in your head, isn't it 1 over x? No, that's the derivative of natural log. We don't know the antiderivative. Like what function has a derivative of natural log? We don't know. So that's how I know I did it wrong. So I must switch. It must be that I have to switch my dv and my u. That's why I'm saying don't write that. Let's fix it, and then you can write this. U should be natural log. dv forces that to be x squared dx. Okay, and then that makes du be 1 over x dx. It makes v be the antiderivative of x squared, so 1/3 x cubed. That's it. And now let's see if this gets us anywhere. It might have to be that you do two, I haven't made the key yet, but it might be that you have to do two integrations by parts, which is fine, that happens all the time. But let's see where we get. And also, we'll talk about the fact that this is a definite integral. All that does is you have to plug in some numbers at the end. All right, so according to our formula, this would be UV minus integral of V du. Let me put the 1/3 out here. All right, V du. And then don't forget really quick that this was a definite integral. So into all these x's, I'm going to be plugging in 1 and e. And this integral right here is still a definite integral, 1 and e. It's like whatever you get at the end, you'll evaluate it at e in that one. All right, so do I want to plug those in now? Sure. So here's me plugging in for this first term, plugging in e and 1, and then I'll deal with this integral in a second. So that would be natural log of e times 1/3 e cubed minus natural log of 1 times 1/3 times 1 cubed, which you can simplify really easily in a second, and then minus 1/3 integral from 1 to e of x cubed times 1 over x. That's going to be just x squared dx. And then that's easy to take the antiderivative of. So we'll do a couple things at once. Natural log of e is just 1. So this turns into 1. E cubed over 3, let me just keep it as e cubed over 3. Natural log of 1 is just 0, so times anything is 0. So this whole term right here is 0. So I won't write it down here. And then antiderivative of all this would be minus 1/3 times antiderivative of x squared is another 1/3 x cubed, evaluated at e and at 1. So finally, e cubed over 3 minus 1/3 times 1/3 e cubed minus 1/3 1 cubed. And you can, you guys know, you can circle this and be done, but this looks like it might simplify, so let me see. This would be e cubed over 3 minus 1/3 times 1/3 is 1/9 e cubed, and then plus 1/9 times 1. Oh, and all of this, oh, no, I don't need the plus c, sorry, because this is a definite integral. And you can keep it here, or this is 3/9 minus 1/9 is 2/9. So finally, that'll be my final answer. Okay, so kind of a weird one because it was a definite integral, and because your u and dv were flip-flopped, and because it was such an ugly, like, our answer is ugly, our functions were ugly. But still, the process was choose your u, choose your dv, take the, use the formula, and then, like, get your answer. All right, nice. We got this one, and is that it? It is, nice. Okay, so this one is kind of crazy, because I told you do integration by parts when you see function times function. And I got more to say about that, I just remembered. So when you see function times function is when you're thinking integration by parts, or, all right, sorry, the lights turned off. When you see function times function, you think integration by parts, or you might be thinking u substitution, because that's also a time when you might see function times function in an integral. But in a u substitution problem, there's going to be an inside function, because that's undoing the chain rule. So if you don't see an inside function, and you do see function times function, then you know that it's got to be integration by parts. But in this case, I don't even see function times function, but I'm telling you it's integration by parts. So this is one of the tricky ones that goes like this. You can think of it as 1 times arc sine of x. And then, like I said, I haven't made a key, so bear with me as I try to remember which one should be u and which one should be dv. All right, if u is 1, then the derivative would be 0. That wouldn't make sense, so let me do it the other way. Arc sine of x will be u, and du will be the derivative of that, which you might not remember, but it is this as I'm writing it. And then dv is forced to be the other thing, so 1 dx. Antiderivative would be x. Okay, this looks like it got more complicated. I don't know how this is going to help. Well, watch this. This is going to be integral of arc sine of x dx is equal to, okay, uv x arc sine of x minus integral of v du. All right, cool. And now look at this dude right here that I'm highlighting. Oh. Look at this dude that I'm highlighting here. That looks like a complicated integral, but one that we know because u substitution would work on this. Hopefully you see that. If you make u be the inside of that square root, 1 minus x squared. And it is a little bit unfortunate that they use u and v for integration by parts and also for u substitution, even though they're kind of like separate things. It's not really, they're not used in the same way, but traditionally that's how it's done. So that's how you're going to see it on the internet and all that. So get used to it. But let me call my u for this highlighted integral. I'm going to say u is 1 minus x squared, which makes du be negative 2x dx. All right, but I don't see a negative 2x dx. I see a negative 1x dx. So let me make this 1/2 du equals, let me just make it negative 1/2 du equals x dx. And so now this turns into x times arc sine of x minus, okay, and then for the second integral, it's going to be minus negative 1/2, so plus 1/2 integral of 1 over square root of u du. Okay, what's the antiderivative of that? Well, just rewrite it as u to the power and then power of negative 1/2, and then go from there. So that would be okay, and now it follows the power rule. So negative 1/2 plus 1 is u to the 1/2, and then divided by the new power, so divided by 1/2 would be times 2. Go back to x's and cancel stuff out. And you get this cancels this, and u was this. So plus square root of 1 minus x squared. What? Where did the square root come from? That's from the 1/2 here. I could have just said 1 minus x squared to the 1/2. But that's the same thing as this. And then plus my c, and I won. And we did it. All right, y'all. Let me know if you have questions. I'm going to end this video before it gets too long. Goodbye. Good job. Good job. Goodbye.